The combined score on the GRE is normally distributed with a mean of 1049, standard deviation of 189 points. So we're now in chapter 7. Okay, so it doesn't matter what chapter we're in, right? On the test, you just have to know what to do. So if I see that, I should be thinking normally distributed. That should be my chart, my z-score chart, the z-score formula. The mean is given as 1049, and the standard deviation is given as 189. Question 1, was a score of a student whose percentile rank is 85th percentile. So that means, so I used to do this in class, right? I would draw the little chart, and this one we're kind of going backwards, right? The chart takes me from percentile to z-score to percentile, and the z-score formula takes me from x value to z-score and vice versa, okay? So the first thing I would need to do is know where I am in terms of z-score. So I'd have to go to my chart and find what the z-score is for 0.85. So let's see, that's 0.85 is a positive, the 85th percentile should correspond with a positive z-score. So I go in here and I just go till I find 0.85, and that's pretty close. Okay, and I won't be too picky about it. Just try and get as close as you can. I'm at 1.04. Right? It should be, the z-score is always going to be 3 significant digits, or 2 decimal places, I guess. 1.04 is my z-score. Okay? So 1.04 is the z-score. So now how do I get x? Well, I set up my equation. 1.04 equals x minus mu, which I know, divided by the standard deviation, which I know, and then I do some algebra. Multiply both sides by 189. And then after I do that, I'm going to add 1049 to that. So my calculation would be 189 times 1.04, and then I'm going to add, the last step of algebra would be to add 1049. I get 1245, so x equals 1245.56. So if I really want to get an 85th percentile, 1245 would be just a little under, so I just round that guy up. 1246, 124, and that's my answer. 1246. Okay, probability question. This is kind of your standard question. What's the probability score is less than 1150? So probability that x is a less than 1150 has to correspond with some z-score that goes with 1150, and I can use my chart for that, right? So I'd have to calculate the z-score, 1150 minus 1049 divided by 189, and that would give me 1150 minus 1049 divided by 189. I get a z-score of 0.534. 0.534, and then I'm going through my chart. So this is one I don't have to worry about doing the 1 minus thing or anything because it's a less than. So z-score 0.534, here's 0.53 is the best I can do, and there's my probability, 0.70194. 0.701. Okay, we can round that as well. Again, I'll be specific on your test of how I want you to round. Do your best. I won't punish you for rounding not exactly how I want you to. Okay. Would a score of 735 be considered unusual? Why or why not? Okay. So let's see. There's 2 ways to answer an unusual question. Give me a z-score if the z-score is really large or really small. And a large z-score is a z-score over 2. A small z-score is a z-score under -2. Now they're going to correspond with just small probabilities, right? Like a 2% chance or something like that. But for us, we've kind of generalized the z-score method. So I'm just going to calculate the z-score. So the z-score is 735 minus 1049 over 189. Should be negative since it's under the mean. 735 minus 1049 divided by 189, negative 1.66. So that's not unusual. So the answer would be no, less than 2 standard deviations from the mean. Okay. We could calculate the probability. Let's see what the probability is. It would be negative 1.66. So the probability of getting less than that would be negative 1.6. Where's the 6? 1.6, 0, 1, 2, 3, 4, 5, 6, right here. So that's a pretty small probability, right? That is only to get less than that score is a 5% chance. So that's pretty small, but it's not small enough, right? To be unusual, it has to be really small, or 2 standard deviations below. Where's 2? Right, here's 2 standard deviations. That's a 2% chance. Okay, so we're saying no, less than 2 standard deviations. And that's all you got to tell me. And for question D, I apologize. That one is also an 8.1 question. That's not supposed to be on there. Sorry about that. I hope that didn't confuse you too much. We'll talk about that after the test. Okay, so that's a pretty good review of the test. Let's see, what else can I ask you about this kind of question? I could give you a question like, what's the probability that it's greater than, right? So you have to think about that a little bit in the chart. The probability that, let's say, x is greater than, we used 1150, then you would have to do 1 minus the probability that x is less than 1150. Okay. Why did I do that? Because that is what the chart will give me, and that we already calculated. Where was that? This guy. So the answer to that one should be about 30%. How about, what else could I ask you? Between two test scores. So what's the probability that I choose one test at random and it's between 1150 and 735. 1150 and 735. That would have to be, I'd have to find 2 probabilities, right? Or 2 values on the z-score. I would do the less than 1150, and then I would subtract from that the less than 735. And let's see, I guess we know what these are. This one was about 0.70, and I think I just looked that one up. It was about 5%. All right, so that would give me something like 0.65. I think that would be right. So I just want to think, those are the questions I can ask you from normal. Greater than, a between 2, a less than we did, and then like question A, we can go back. Okay.